All right, and I know I already told you guys, but just for the recording purposes, you can use an index card as kind of like a cheat sheet tomorrow on the final exam. Those are some examples that I pulled off of Google, so really like maximize your space right on both sides, whatever formula or definition you need for tomorrow, or for the illuminate portion that you're taking next week. So that is something that district just said that we could do. So if you want to take advantage of it, that's something that could give you a little boost. Something else that could give you a boost for tomorrow is doing more than just your minimum of one choice per unit. So if you decide to do more than that, it will not hurt you at all. It can only benefit you assuming that it's right, and really you could get a 200% on that portion if you get everything right. So great way to get some extra credit on your final exam. So today you can ask questions on either review. It could be the packet, but we did a lot of it yesterday. Or it could be from the presentation. So any questions that you need more help on? Okay, now. Oh, you're good? One. On the packet. The last page of the packet is a problem that looks something like this, right? It's a 4B. Okay. So that last page of your packet, like on the front of that page, there's an example. So that's kind of nice. And then 4B is like practice. So, and this is also really similar to what was on the constructed response. If you thought that was for like our most recent unit test. So if you thought that was easy, then I would pick this one for choices. Anyway, it says P is the function that gives the cost in dollars of mailing a letter from Japan to the United States based on the weight of the letter in ounces. And this is the last page where it says 4B. It looks a little different, but it's the same concept. The function is defined by this set of rules. So you have to know how to read the rules. Like, what is that 1.75 referring to? It's not an input. It's the price, which would be the output, because doesn't the price depend on something? What does it depend on? The weight of the package or whatever, letter. So that's what depends on something else. That's my output. That's what my Y value. The other part tells me my input, and the way that it's written tells you basically for like the first one, it costs 175 from above 0 to 1.5. And then above 1.5 to the 2, it's a different cost, and that's how you read it. So when it says how much does it cost to send a letter that weighs 1.8 ounces, how much does it cost?
2.03.
And why?
Then the 1.8 is in between the 1.5 and 2.
Good. So 1.8 falls between these two numbers. So that is what it costs. This is my input, and it says when my input is between these two numbers, that's my output. What about the 3.5 ounces? Good. Now that one, pretty straightforward. What if they ask for like 2 ounces? So 2 is listed twice. It's listed up here and over here. How do you know which one to use?
You would use the one that says $2.03 because on the last one it has to be greater than 2.
Yes. So one of them has an equal to part and the other one doesn't. So the 2.03 has it where it can be 2 also. So that is why for a 2-ounce one exactly, it would still be $2.03, not 2.7 cents. So good, so you know how to read the rules. To graph a function on the coordinate plane, use your symbols. So the ones that look like this, or they could look like this, what type of circles could those have? Open circles. And then the ones with the lines underneath would have closed circles. So then make sure that lines up. What's gonna be the first thing that I graph, like what coordinate? According to the rule. 0 for the x, what for the y? 1.75. And then based on this symbol, what type of circle will be on that one? Open circle. I should hear more than one circle. They're all thinking one. But yeah, so open circle on the 0, 1.75, so right there. For it, you don't get them flopped, and then there's 2 decimals, but this is an output. Price it, so it should go on the y spot. All right, and then keep it going. The next coordinate would be what? Someone from table 1, what was the next one? Okay. 2 and what? No. Okay, so since you started with this 2, we can jump to that one. I mean, yeah, we still need to graph the 1.5 and put 2. But we will have a point on the 2.03. What type of circle will be on that one? A closed one, because that one has the equal to part in there. So we'll get to that one. Class, what about for the 1.5? What's the output? 1.75. And then what type of circle will we have on this one? Close. So then going back to the graph, find 1.5 and 1.75, have a closed circle. And then according to the rule, everything in between those 2 points cost the same, don't they? So you need to have like a level solid line between them, because it costs the same. The question? Very last page. All right, and then keep it going. Now we're on the next line. We already have like the closed circle part of the next line. What would be the open circle part? So 2.03 for the output. What x value? 1.5 is where it starts at. But since it's not the equal to part, that's why it's an open circle. So where it's 1.5 and 2.03, so a little above that, we have an open circle. And then we already said the closed circle would be at 2 on the x, 2.03 on the y, and then connect them because they cost the same. All right, they do not need to be an equal length. I think I saw that in some of the responses on the constructed response. It just depends on the rule. All right, we still have one more segment according to this. So the 2.76 is an input or an output. An output, so put it in the y spot. Where does it start to be that value? So then open or closed circle? Open. So then 2.76. About here, there's an open circle. 2 on the x, 2.76 on the y, and then when does it stop costing that much? 3.5, so there will be a closed circle on the same height as this one. They have the same price, and then in between them, it's the same price, so it's next. All right, and there's no other costs other than that it says, so then we're done. Good? And then I think the last part, it has you like basically summarizing what's going on. So connect it to the real world situation. You can look at the page in front and it has it literally typed up. All you would have to do is replace the numbers if you wanted to use what they said. But really, like, I don't think you even need it as long as you understand what's going on. Like you could say anything above 0 up to 1.5 costs 1.75 or whatever it was. Everything above 1.5 up to 2 costs 2.03. And just explain each cost. And make sure, like for the open circles, you say above because it doesn't include the 0. And like here, it doesn't include the 1.5. But then for the closed ones, you can say up to. Good? Okay, any others from the packet or from the puzzle piece? Okay, that one you can cross out, so that's unit 3 and unit 2. Yeah, or just who was after saying, you know? Okay, so you can do that. And then we'll grab it. Any others from either the packet or the puzzle piece? No one's really asked me about the puzzle piece, so I hope you guys like that. Or that you thought it was easy. All right, so let me look at the choices again. For what you're doing tomorrow. Can you all make a box plot?
Yeah.
You all know it's needed to make a box plot. If not, maybe jot it down for something to write on the note card you're gonna make later yourself, if you choose to make one. Do you guys know how to make a histogram?
What's that?
It's kind of like a bar graph, except for that there's intervals versus just like a normal standard bar graph.
Oh.
So let me show you a few examples just like on Google, because I feel like that would be better. But yeah, if you're making just a normal bar graph where each bar is just for one number, then that would be incorrect. It has to be intervals. So I don't know. I can't zoom in the way I want to on here.
Do they have to be present?
Yes. Histograms have bars that are touching. So yeah, they have intervals. So this first bar in this random picture that I pulled up has it from 0 to 5. But then also notice that it has this bar labeled as 5 to 10. If it's labeled like this, really it should be like even amounts in each bar and they shouldn't overlap. All right, if it shows it as overlapping, then know that. So let me see if I have an example. So if they overlap, like where it is, instead of having the intervals listed like that, maybe they have it like this, which makes it hard to tell like what goes in what bar. So if it's labeled like how I labeled it in red, just know that if it's 5 exactly, it would go in this bar, according to like histogram rules. So in reality, this bar right here just has from 0 to 4. This one would have from 5 to 9. This one would have from 5 to 10, or not 5 to 10. 10 to 14, because your histogram should have like even intervals. And if it's the maximum number in that interval, it moves to the next one. So it's kind of weird, but that's how it is. So then when you're making a histogram, they already have it for you, the frequency. So you just have to make sure you're putting it at the right places. So from 6 to 8, so starting at the 6, ending at the 8, we have 4 members. Like that. Starting at the 6, ending at the 8. And then starting at the 9, ending at the 11, it's 2. So, oh, that's not 2. 2 is down here. So then starting at the 9 to the 11 would be there. And yes, they do have to be touching. All right, so your y-axis for histogram is always frequency. It's how often something from that interval appears in the data set. So questions on that, Brian?
So you know how from 21 to 24 is still 25, 27, but at 28 to 30 is 1, how, where do you go?
So then those would be the only intervals that have nothing. So I guess these would all touch then, and this one would be separate just because these are 0. So a lot of the time people, and that happened on the first constructed response, they put these skinny little bars all separated out, and I had to dock you points because they're supposed to touch. All right, any other questions about this, about any of the reviews? So you guys know how to find mean, median, standard deviation, quartiles, interquartile range. You know how to determine if something's an outlier or not. Okay, so how do you find an outlier? There's a specific formula you use. And here it is. It's this option is not on your paper, but like I mentioned before, just some people don't listen. Because I say it and then they're like, "This is not on our paper." I'm like, "Yeah, I know. I've said it many times." This is not on your paper. It's only on the file that is in Schoology if you want to look at what all the possible options will look like. But for outliers, you have a formula for when you're looking at a lower extreme versus a higher extreme. So basically, if it's 1.5 times the IQR plus whatever your third quartile is, if it's higher than that, then it's an outlier. So that's what the first one is your upper extreme. So that you would use to test numbers that are like to the far right of the rest of the data, because if it's 1.5 times the IQR plus a whole third quartile over, then it's an outlier. And then for the other one, that would be for like a lower extreme that you're testing. If it's smaller than 1.5 times the IQR, and I think I wrote that bad actually. So if you wrote this one, write it like this instead. It's Q1 minus, not the other way around. Q1 minus 1.5 times the IQR. And you would use to test stuff that would be on the far left. So maybe if you want to test if 0 is an outlier or not. So when I ask people, like, how do you know something's an outlier? They'll say, oh, if it's really far away from the data. But on your constructed response, it does ask to explain your reasoning with mathematical calculations. And that's the rule. If it's greater than 1.5 times the IQR, and then whatever quartile is closest to it, if it's that much farther. Good? All right, let's see what else is on here. You guys know how to calculate standard deviation? What's the only way that we know how to calculate it at this level? Using Desmos. That's the only way you guys know how to calculate it. Or if you have like a graphing calculator and you know how to use it, that's the only way that we taught you. So there is a way to do it by hand, but that takes like at least 10 minutes and we didn't teach it to you. So you'll learn it in Algebra 3-4. So in Desmos, you would take down a list of your data just like that. Name it, I use D for data, equals, bracket, and then you just type in your numbers. So if I was doing this problem from a dot plot, I would type in 0, comma 10, comma 10, comma 30, comma 30, and I would keep going. I would just end there though for calculating standard deviation. And then once you have your list, definitely make sure however many data points it says right here matches how many you have over here. And then in your keyboard, you have this functions menu with all this stuff in it. This unit was statistics, unit 1. So here's standard deviation. And there's actually 2 standard deviations you could use. So if it was like multiple choice, they're really similar. It's one of these 2. All right, one is for the population, one is for not the population. It really doesn't matter. They're very similar. Also, you could look up other things if you notice in that statistics menu. You could find ways to do the mean the same way, the median the same way, just typing in D and it gives you an answer. But I would just use that to verify. You still need to know how to do it by hand. So good. Any other questions from either of you? All right. So then if you think of something, let me know. I'm going to come around and give you points for your packet. So when I come by, just flip through the pages for me.